Okay, so now we are going to discuss kinetic theory of gases. Listen, this theory, it deals with microscopic basis of gas laws. It deals with microscopic basis of gas laws. Okay, take note. Then next information, according to kinetic theory of gases, see, a gas consists of huge number of particles, called molecules. Each and every gas consists of huge number of particles called molecules. Okay, and these particles, they are not large particles, they are all microscopic, very, very small. They are all microscopic particles. Okay, each and every gas contain huge number of microscopic, very, very small particles, microscopic particles, and these particles are actually called as molecules. Okay, and in gas, these molecules are always in motion. Okay, they are always in random motion. Okay, they move here and there like that. Okay, random motion. That is the reason why it is called kinetic. They are not static. The molecules are keep on moving here and there, so it is called kinetic theory. Okay, and listen carefully. This kinetic theory is also applicable for ideal gas only. Kinetic theory is also applicable for ideal gas. Okay, because according to kinetic theory, there is no interaction between molecules. There is no interaction between particles, also called molecules. There is no interaction between molecules. Okay, no interaction means, right, we call that gas as ideal gas. So remember, kinetic theory of gases is applicable only for ideal gas. Okay, and this is another important point. According to kinetic theory, what is the volume occupied by each molecule? Listen, each molecule in the gas, okay, they are assumed to be point masses. Each molecule is assumed to be point mass. Therefore, the volume occupied by molecule is negligible. So, volume occupied by a molecule is negligible. Okay, each molecule, the volume occupied by each molecule is negligible. Okay, take note. The volume occupied by each molecule is negligible. Okay, take note. Listen, one molecule and another molecule, they undergo collision. One molecule and other molecule undergo collision, and these collisions are elastic collisions. Okay, what is meant by elastic collision? See, for example, assume that this molecule has some energy 5 joule and this molecule has some energy, say 3 joule. 5 joule and 3 joule. What is the total energy?
8 joules.
8 joules. So before collision, total energy is 8 joule. Okay, they collide each other. Then after collision, listen, during collision, they share their energy. After collision, suppose after collision, this molecule has energy, say for example, 2 joules, and this molecule has energy 6 joule. What is the total now?
Same, sir. 8 joules.
Same. So, energy, total energy before collision, total energy after collision are equal. That's the reason why these collisions are called as elastic collisions. Okay, take. I repeat. Listen. Suppose you take molecule A and assume that this molecule collide with another molecule. Then after the collision, molecule A moves in straight line and again collide with another molecule. Okay, between these two collision, here it is colliding with this molecule, right? After that it collides with this molecule, right? Between these two collision, it travels a distance d1. After making collision with this molecule, again the molecule A moves in the same straight line and collide with another molecule here. To make the next collision, it travels a distance d2. Similarly, it travels a distance d3, d4 for adjacent collisions. Okay, now you take the average. Okay, find the distance traveled by the molecule and divided by the number of collisions, right? Or divided by the distance, how many distance it traveled, okay, number of distance. You will get what is called mean free path. So mean free path, what is mean free path? Mean free path is nothing but average. I'll write simply like this: average distance traveled, average distance traveled by a molecule for two successive collisions. For two successive collisions. This is what we call as mean free path. Okay, take note. Listen. Based on the change in momentum principle, change in momentum ideas, we can derive an expression for pressure of the gas through theoretical method. Through theoretical, we can derive, but here I am not going to discuss how to derive that equation. Okay, I am giving you only the final expression, and this expression is what we call as kinetic theory equation, which is nothing but PV is equal to 1 by 3. This is number 3. 1 by 3 mnu RMS square. What is P? P is nothing but pressure of the gas. V is nothing but volume of the gas. I have told you already, kinetic theory equation is applicable only for ideal gas. So this is pressure of the ideal gas, this is volume of the ideal gas. And we have some number 1 by 3 here. What is M? M is nothing but mass of one molecule. Take down. What is M? M is nothing but mass of one molecule. Mass of one mole. What is N here? This N is not number of mole, it is actually number of molecules present in the container. Number of molecules. What is this URMS? You know very well. What is URMS? URMS is nothing but root mean square velocity. Yes.
Velocity.
Yes.
Velocity.
Yes, you are right. Root mean square velocity. Take the square of URMS. Take the square of URMS and multiply with this quantity, you will get PV. Okay, and this equation is what we call as kinetic theory equation. Okay, take down. Take down. Take down. So here I have written average velocity is equal to velocities of individual molecule, add them, divided by total number of molecule, you will get average velocity. What is average of the square velocity? Take the square velocities of individual molecule, add them and divided by total number of molecule, you will get average of the square velocities. Then what is URMS? Root mean square. See, root mean, this symbol indicate mean, and square velocities. URMS. Take square both side. On squaring both side, you will get URMS square, and this side if you take square, root will go, so you will get this. What is meant by that? Square of the root mean square velocity is nothing but average of the square velocity. Okay, take down. Okay, take the square of the root mean square velocity, which is nothing but average of the square velocities. Right, take down. I'm going to discuss about Maxwell's distribution of velocities. According to this, if you take a gas, right, the gas consists of molecules. These molecules are moving randomly here and there. The point here is not all molecules have same velocity. Okay, at any instant if you take, right, not all molecules have same velocity. Actually, velocity is distributed among molecules. What's the meaning? Suppose if you take 1000 molecules in the container, out of 1000 molecules, say for example 20 molecules have some velocity u1 at a particular time. Then another 50 molecule may have some velocity u2, right? Or you can also write the c1, c2. Then another 75 molecules or 100 molecules, whatever it is, have velocity c3. So velocity is distributed among the molecules. Now what I'm going to do, what is the fraction of molecules having velocity between c and c plus dc? C is the velocity of molecules having velocity c, and c plus dc is some small additional velocity. Okay, now what fraction of molecules, okay, are present between c and c plus dc? Okay, that I am going to represent as p of c into dc. What is p of c into dc? P of c into dc is nothing but fraction of molecules, okay, fraction of molecules having the velocity range dc, right, which is nothing but dnc by n. What is dnc? dnc is nothing but number of molecule having velocity in the range c and c plus dc. What is dnc? dnc is nothing but number of molecules having velocity c and c plus dc. Okay, so in this range, how many, what is the fraction of molecule available? This is the formula. Okay, I'm not, actually we can derive, I'm not going to derive here, I'm going to give you only the final answer. What is the final answer? See, the fraction of molecule having, yes sir, yes. Okay, so this is the equation for Maxwell's distribution of velocities. If you plot P of C versus C, you will get a curve like this, and the maximum point, this is the maximum point, and this population, this number of molecule, it is the maximum fraction of molecule. Maximum fraction of molecule have some velocity that is called most probable velocity, and we can derive most probable velocity from this equation. I didn't show the derivation, but we can derive, and the most probable velocity is equal to square root of 2 RT by m, where 2 is constant, R is gas constant, T is temperature in Kelvin, m is the molar mass, and molar mass should be in kilogram. Okay, now observe carefully. You know very well the kinetic theory equation. PV is equal to 1 by 3 m n u r ms square. Bring this 3 to the left hand side, so 3 into PV is equal to m. M is nothing but mass of one molecule. Keep this in mind, mass of one molecule. Right? Suppose if you take 1 mole of gas, if you take 1 mole of gas, then this number of molecule become Avogadro number. It becomes Avogadro number. Okay, n is nothing but number of molecules. It is not number of mole. Be careful. Okay, n is not number of mole. It is number of molecule. If you take 1 mole of gas, then the gas contain Avogadro number of molecule into URMS square. Mass of one molecule into Avogadro number is nothing but molar mass. So 3PV equal to molar mass into URMS square. Okay, In the case of ideal gas, PV is equal to RT for 1 mole, right? For 1 mole of ideal gas, PV equal to RT. So in the place of PV, you put RT. So you'll get 3 into RT by M equal to URMS square, URMS square. Now take square root, you'll get URMS. So what is URMS? URMS equal to square root of 3RT by
3RT by M.
M. Take. Okay, I can give you the formula directly. Average velocity is equal to square root of 8RT by pi into M. This also we can derive, but I am not going to do. It is somewhat lengthy process. I am not going to do. Okay, I am giving you the final answer directly. So remember, there are 3 velocities. Okay, in the Maxwell's distribution of velocities of molecules. What are they? Most probable velocity, which is square root of 2RT by M. Then root mean square velocity, which is nothing but square root of 3RT by M. Then average velocity, which is nothing but square root of 8RT by pi into M. Okay, take down. Remember all these 3 velocity formulas. Okay, take down.
2MP, sir.
Very good.
Most probable velocity.
Most probable velocity. Then
average velocity.
Then
Then root mean square velocity, sir.
Yes.